Close your eyes for a moment and imagine stepping out of your front door into a world that looks nothing like the one you know. The year is 400,000 years before present. You're standing somewhere in what will one day be called England, but you wouldn't recognise it. The Thames Valley stretches before you, but it's not the gentle river you might picture. This is a wider, wilder waterway cutting through a landscape that shifts between lush temperate forest and frozen tundra, depending on which decade you've arrived in. Because here's the thing about Earth 400,000 years ago. It was caught in the grip of massive climate cycles. Not the gentle seasonal changes we experience today, but brutal swings between glacial and interglacial periods that could transform entire continents within a few thousand years. Imagine living through climate change so dramatic that within your great-grandparents' lifetimes, forests became grasslands, rivers froze solid for months on end, and the coastlines shifted hundreds of miles as sea levels dropped and rose again. You're living during what scientists call the Middle Pleistocene, and if there's one word that captures this period, it's unstable. The planet was locked in a rhythm of ice ages, each one lasting roughly 100,000 years. For 90,000 years, ice sheets would grow, spreading south from the polar regions, covering vast portions of Europe, Asia, and North America under glaciers sometimes 2 miles thick. Then, in what amounted to a geological eye blink, maybe just 10,000 years, the ice would retreat, temperatures would surge, and the world would enter a brief warm period called an interglacial. 400,000 years ago, you'd be living right in the middle of one of these cycles, not at the peak of glaciation when ice covered London, not in the warm respite of an interglacial, but somewhere in between. A world that was colder than today but not brutally frozen. A landscape caught in transition where the rules were always changing and nothing stayed the same for long. But the truly shocking thing about this world, the detail that would stop you in your tracks if you could actually visit this time, isn't the climate. It's not the megafauna, though those would be spectacular. Straight-tusked elephants larger than modern African elephants, rhinoceroses that would dwarf their contemporary descendants, cave bears that would make grizzlies look small. No, what would really shake you is something far more unsettling. You are not alone. Not in the way you understand being alone as a modern human. You're not the only human species on the planet, not even close. In fact, 400,000 years ago, Earth was home to at least 3, possibly 4, or even 5 distinct species of humans. All of them intelligent, all of them using tools, all of them competing for the same resources across the same landscapes, all of them solving the same survival problems in different ways. This isn't like the diversity of human cultures we see today. We're not talking about different ethnic groups or tribes. We're talking about actually different species, as different from each other as lions are from tigers, as wolves are from coyotes. They couldn't all successfully interbreed. They had different body plans, different skull shapes, different brain structures. They were humanity's family tree, but the tree was still bushy, still branching, with multiple lineages all trying to survive at the same time. In Europe, populations of a species called Homo heidelbergensis dominated the landscape. These were big humans, robust and powerful, with brains nearly as large as modern humans. They stood around 6 feet tall, massively built, with thick bones and heavy muscles suited for the demanding physical life they led. Their faces projected forward more than ours, with prominent brow ridges shadowing deep-set eyes, and their skulls were elongated rather than rounded. But don't mistake these anatomical differences for primitive simplicity. These were sophisticated hunters who had mastered fire, who made elegant wooden spears capable of bringing down massive prey, who cared for their injured and possibly buried their dead. Meanwhile, in parts of Asia, particularly in Java and possibly in China, the last remnants of an even older human species, Homo erectus, were clinging to existence. Erectus had been the most successful human species in history, spreading from Africa across Asia nearly 2 million years earlier, lasting longer than any other human species before or since. But by 400,000 years ago, they were in decline, reduced to isolated populations in refuges where they could still compete. They were the grand old lineage of humanity, the pioneers who had first left Africa, first mastered fire on a large scale, first spread across 2 continents, but time was running out for them. And somewhere in this mix, populations of Homo heidelbergensis in Europe were beginning to change. The harsh conditions of glacial Europe were moulding them into something new. They were developing thicker, stockier bodies better suited for conserving heat. Their faces were becoming more projecting, their noses larger and more internal volume, adaptations that helped warm and humidify the frigid air they breathed. These populations would eventually become Neanderthals, though in 400,000 BCE they were still in transition, showing just the earliest hints of what would come. In Africa, things were even more mysterious and more important, though we barely understand them. African populations of Homo heidelbergensis were also changing, evolving in response to their own set of environmental pressures. These populations would eventually give rise to us, to Homo sapiens, to anatomically modern humans. But 400,000 years ago, that transformation was still hundreds of thousands of years away. The African fossil record from this period is frustratingly sparse, leaving us with more questions than answers about what was actually happening on the continent that would eventually produce our species. Think about what this means for a moment. 400,000 years ago, the world was populated by multiple species of humans. They weren't ancient history, they weren't fossil curiosities. They were living, breathing, thinking beings, each trying to survive in a world that was constantly trying to kill them. They hunted the same animals, sought shelter in the same caves, gathered around the same water sources during droughts. They must have known about each other, must have encountered each other, must have made decisions about whether to fight, flee, or cooperate when their paths crossed. The evidence for all of this is scattered and fragmentary, pieced together from bones found in caves, from stone tools left at ancient butchery sites, from hearth remains that tell us about fire use, from the rare, precious footprints preserved in ancient mud. But even with all these gaps, the picture is clear enough. This was not a world with a single human success story playing out in isolation. This was a world where multiple human experiments were running simultaneously, where different solutions to the same survival problems were being tested in real time, and most of them would fail. By the time we get to 40,000 years ago, all but one of these human species will be extinct. Homo erectus, gone. Homo heidelbergensis, gone. The Neanderthals, who hadn't even fully evolved yet in 400,000 BCE, would rise to dominance in Europe, and then they too would disappear. Eventually only Homo sapiens, modern humans, our species, would remain. But here, in the middle of the Middle Pleistocene, that ending was still unwritten. The world 400,000 years ago was humanity at its most diverse, multiple species all struggling to survive in an unstable world, all innovating, all adapting, all competing for a chance to pass their genes into the future. The fossil sites that give us glimpses into this world are scattered across 3 continents. In England, at a site called Boxgrove, archaeologists found butchered rhino bones alongside sophisticated hand axes, evidence that Homo heidelbergensis were taking down the largest game animals in their environment. In Germany, at Schöningen, they found wooden spears 400,000 years old, preserved in a peat bog, elegant killing tools shaped and balanced with remarkable skill. In Spain, at a site called Atapuerca, at the bottom of a cave system in what's called the Cima de los Huesos, the pit of bones, researchers found the remains of at least 28 individual Homo heidelbergensis, along with a single beautiful hand axe made of pink quartz, possibly placed there deliberately. Each of these sites is a window into this vanished world, a moment frozen in time that lets us glimpse how these humans lived. But for all we've learned, there's so much more we don't know. How often did different species encounter each other? Did they fight when they met? Did they cooperate? Did they interbreed? Or were they too different for that to work? Did they have language? Did they have culture, stories, beliefs about the world? The bones can tell us some things. The tools can tell us others. But there are questions that 400,000-year-old stone and fossilized bone simply cannot answer. Questions about thought and feeling, about consciousness and culture, about what it was like to be human in a world so different from our own. If you're listening to this to fall asleep, you're in the right place. That's exactly why I make these videos. So maybe take a moment to subscribe, and if you're feeling generous, drop a comment telling me where you are right now and what time it is. I love seeing the timestamps. Someone in Sydney falling asleep at sunrise, someone in New York at 2 a.m, someone in Dubai during an afternoon break. All of us, modern humans, the only human species left, wondering about the cousins we lost along the way. Because that's what this story is really about. It's about family, a very strange, very distant family, where the different branches were different species, where the family reunions would have been tense affairs if they happened at all. But family nonetheless. Every human alive today is descended from the populations that survived this period. We carry in our genes and in our bones the legacy of ancestors who lived through climate catastrophes we can barely imagine, who competed with other human species and somehow came out on top, who innovated and adapted and passed on their knowledge and their DNA until, eventually, their descendants became us. 400,000 years ago, the question of which human lineage would survive and which would go extinct was still completely open. The world was full of humans, plural, and the outcome of their struggles would shape the entire future of our species. This is the story of that world, of those humans, of the 400,000-year-old moment when humanity's family tree was at its bushiest and its most competitive. This is the story of when multiple human species fought to survive. Let's get to know the dominant human species of this period, Homo heidelbergensis. The name comes from Heidelberg, Germany, where the first specimen, a massive jawbone, was discovered in 1907 in a sandpit near the village of Mauer. The worker who found it recognized it as something unusual, something that didn't quite match any animal he knew, and that jawbone would end up rewriting our understanding of human evolution. But that single jawbone, remarkable as it was, tells us far less than what's been discovered since, because over the past century paleontologists have found Homo heidelbergensis remains across a vast geographic range, from England to South Africa, from Spain to Ethiopia, from France to Zambia. This was a species that had spread across 2 continents, adapting to environments ranging from the forests of temperate Europe to the savannas of Africa, from coastal regions to inland mountains. And what these fossils reveal is a human species unlike anything alive today. If you could encounter a Homo heidelbergensis walking toward you across an ancient landscape, your first impression would be size. These were large humans. Males averaged around 6 feet tall, but they were built on an entirely different plan than modern humans. Where we're relatively gracile with slender bones and lean muscle, they were robust. Thick bones, massive muscle attachments, bodies built for a life of relentless physical demands. Their skulls show this robustness even more clearly. The skull bones themselves were thicker than ours, sometimes twice as thick. The brow ridges over their eyes were pronounced, creating deep shadowing that would have given their faces a distinctive appearance. Their faces projected forward more than ours, with larger teeth and more powerful jaws. The back of the skull was elongated rather than rounded, and the skull sat on the spine differently, reflecting subtle differences in posture and movement. But here's what's really interesting. Their brains were almost as large as ours. The average Homo heidelbergensis brain was around 1/200 cubic centimeters, compared to the modern human average of about 1/350. That's not a huge difference. In fact, some Homo heidelbergensis individuals had brains larger than some modern humans. Brain size alone doesn't tell you everything about intelligence, but it tells you something. It tells you that these were not primitive creatures stumbling through life on instinct alone. These were thinking humans, problem-solving humans, humans with the cognitive capacity for complex planning, for social coordination, for innovation and cultural transmission. And we know this not just from their skulls, but from what they left behind. The tools, the kill sites, the living spaces, the evidence of fire use, all of it points to minds capable of abstraction, foresight and adaptation. Let's start with the hunting, because this is where Homo heidelbergensis really showed their capabilities. These were not scavengers, picking at lion kills or opportunistic hunters taking whatever they could get. These were apex predators, and they were targeting the largest, most dangerous animals in their environment. At Boxgrove in England, archaeologists found a site dating to about 500,000 years ago, right in the heart of the Homo heidelbergensis period. The site preserves a moment in time, a butchery site where a rhinoceros was killed and processed. Not a small animal. Not something you could take down with luck and a thrown rock. We're talking about an animal weighing over 2 tons with thick hide and the temperament of a tank. The butchery marks on the rhino bones tell a story of systematic, efficient processing. The hunters knew exactly what they were doing. They removed the meat in a specific order, accessing the richest parts first. They broke open bones to access the marrow. They used different tools for different tasks. Hand axes for the heavy cutting, smaller flakes for delicate work. This wasn't just killing an animal and tearing into it. This was skilled butchery, the kind that comes from deep knowledge passed down through generations, and the rhino wasn't an exception. At the same site, they found butchered horses, deer, even straight-tusked elephants. These Heidelbergensis hunters were taking on the megafauna of Middle Pleistocene Europe and winning. Elephants that stood 13 feet tall at the shoulder, rhinos that could charge at speeds that would give you maybe seconds to react. These were not easy prey, so how did they do it? How did relatively small groups of humans, armed with wooden spears and stone tools, bring down animals that modern hunters would approach only with high-powered rifles? The answer is a combination of intelligence, cooperation, knowledge, and tools that were far more sophisticated than you might imagine. In 1994, at a site called Schöningen in Germany, archaeologists made a discovery that changed everything we thought we knew about Homo heidelbergensis hunting technology. They found spears. Not stone spear points attached to wooden shafts, but complete wooden spears, preserved for 400,000 years in a peat bog that had protected them from decay. These spears were not simple sharpened sticks. They were carefully crafted weapons, each one shaped from spruce wood, chosen for its combination of strength and flexibility. They range from 6 to 8 feet long, and here's the crucial detail. They were balanced. The centre of gravity was positioned about a third of the way from the pointed end, exactly where you'd want it for a throwing spear. These were javelins designed to be thrown at high velocity into large game. Testing with replicas has shown that these spears, thrown by someone with practice, could penetrate deep enough to cause fatal wounds to large animals. They could be thrown accurately up to about 60 feet, giving hunters the ability to strike from a distance before the animal could charge. This was sophisticated weapons, technology, the kind that requires not just knowledge of materials and shaping techniques, but understanding of physics and ballistics, even if that understanding was intuitive rather than theoretical. But weapons alone don't bring down elephants. You need strategy, you need coordination, you need a group of hunters working together with practiced efficiency, and this is where Homo heidelbergensis, social complexity, becomes crucial. The evidence suggests they hunted in groups, coordinating their attacks. At some butchery sites, the concentration of bones and tools suggests multiple hunters working simultaneously. The size of some of the kills, straight-tusked elephants weighing 8 or 10 tons, would have required many people to process the carcass before scavengers arrived. This wasn't individual hunting. This was group effort requiring communication, planning, and role specialization. And here's where it gets really interesting. There's evidence that Homo heidelbergensis were among the first humans to systematically use fire for purposes beyond just warmth. Fire became a tool in their hunting arsenal. At several sites across Europe and Africa, archaeologists have found evidence of controlled burning in patterns that suggest deliberate landscape management. Small controlled fires that would have cleared underbrush, creating more open areas that would attract grazing animals. Fires that might have been used to drive game toward waiting hunters. Fire as a weapon. Fire as a tool for reshaping the environment to make it more productive for human use. The hearths themselves tell another story. At many Homo heidelbergensis sites, you find carefully constructed fire pits, often in the same locations used repeatedly over long periods. These aren't just random campfires. These are engineered structures, often with rocks placed to reflect heat, sometimes with evidence of careful fuel selection. Different woods burn at different temperatures, produce different amounts of smoke, provide different qualities of light. Homo heidelbergensis seemed to understand these differences and use them strategically. Fire would have been the centre of social life. Imagine the scene. Evening falling over a Middle Pleistocene landscape. The hunting band returns to their shelter, a rock overhang or a constructed hut. Someone tends the fire, feeding it carefully selected wood. Others begin processing the day's kill, using the firelight to work by as darkness falls. Children watch and learn, seeing how meat is cut, how hides are prepared, how bones are broken open for marrow. Older members of the group share their knowledge, perhaps through a combination of demonstration and vocalization that we might recognize as the roots of language. Because here's a question that haunts everyone who studies Homo heidelbergensis. Could they talk? The anatomical evidence is tantalizing but frustratingly incomplete. The base of the skull, where nerves pass through to control the tongue and larynx, suggests they had neural control comparable to modern humans. The hyoid bone, which anchors the tongue and is crucial for speech, has been found in Homo heidelbergensis specimens and looks remarkably similar to ours. The thoracic vertebrae, The bones of the upper spine show adaptations that some researchers interpret as necessary for the fine breath control required for speech. But anatomy only tells you about capability, not about use. Plenty of animals have the physical equipment for complex vocalizations but don't use them for language. Parrots can mimic human speech perfectly, but aren't using language in the way we do, so we can't say for certain that Homo heidelbergensis had language as we understand it. What we can say is that they had complex culture, and complex culture requires information transfer. The hunting techniques we've discussed, the careful tool making, the fire management, the butchery knowledge, all of this had to be taught. You don't figure out how to make a balanced throwing spear by trial and error. You don't learn which wood burns hottest, or how to track wounded game across miles of terrain through individual experimentation. This knowledge was accumulated over generations and passed down, and that requires some form of sophisticated communication. Whether it was true language with grammar and syntax, or a more limited proto-language combining vocalizations with gestures and demonstrations, we can't say for certain. But they were communicating complex information, and that alone is remarkable. The social sophistication goes even deeper. At the Cima de los Huesos site in Spain, the pit of bones we mentioned earlier, researchers found something extraordinary. 28 individual Homo heidelbergensis, all found at the bottom of a deep cave shaft. The individuals range in age from children to older adults. They show various pathologies, evidence of disease and injury, and they were all deliberately placed there. This wasn't where they lived. The cave shaft was difficult to access, deep underground. There's no evidence of habitation, no living surfaces, no concentration of tools or food remains. Except for one thing, a single hand axe made of beautiful pink quartz, a material not local to the area. It was made with exceptional skill, symmetrical and elegant, and it shows almost no signs of use. What researchers found in that pit was either the earliest evidence of deliberate burial or the earliest example of caring for the dead by placing them in a specific location. Either way, it suggests something profound about Homo heidelbergensis minds. They were doing something with their dead beyond just leaving them where they fell. They were investing effort, going through elaborate processes, possibly with some notion of ritual or respect. Among those 28 individuals, several show evidence of significant injuries or pathologies that would have left them disabled. A teenager with severe spinal deformity, and an adult with a badly healed fracture that would have limited mobility for months. And yet they survived to adulthood, or in some cases to old age. This is evidence of care. Someone helped them. Someone fed them when they couldn't hunt. Someone protected them when they were vulnerable. This isn't unique to humans. We see care behavior in other primates, even in some non-primates, but the extent of care shown in these Homo heidelbergensis remains goes beyond simple compassion. It suggests complex social bonds, perhaps even a sense of obligation to group members, the kind of social safety net that requires culture to maintain. The living sites show similar sophistication. At Terra Amata in France, archaeologists found evidence of constructed shelters, not just natural caves or rock overhangs, but deliberately built structures, post holes where wooden supports were placed, arrangements of stones that appear to have been foundations or walls. These were temporary structures, probably rebuilt seasonally, but they show planning and engineering beyond what many people assume about humans this ancient. The shelters were oriented to take advantage of natural features, positioned to block prevailing winds, placed to maximize sunlight during cold periods, located near water sources but on high enough ground to avoid flooding. This is sophisticated environmental knowledge, the kind of practical wisdom that accumulates over many lifetimes of living in a place. And they were adapting to remarkably different environments. Homo heidelbergensis in Africa were dealing with seasonal droughts, with lions and leopards and hyenas. Heidelbergensis in Europe were dealing with ice age conditions, with winters that could kill and summers that were brief and precious. Yet both populations thrived, which tells us something important about their flexibility. They weren't specialized for one narrow ecological niche. They were generalists capable of adjusting their strategies to whatever environment they found themselves in. This adaptability, more than any single trait, is probably what made them so successful for so long. But success in evolution is always temporary. Homo heidelbergensis would eventually disappear, their populations in Europe evolving into Neanderthals, their populations in Africa evolving toward modern humans. By about 200,000 years ago, Homo heidelbergensis as a distinct species would be gone, transformed into its descendant species. But 400,000 years ago they were at their peak, the apex predators of multiple continents, master hunters with sophisticated tools and weapons, social beings capable of complex cooperation, and possibly the earliest stirrings of symbolic thought. They were humanity at a crucial crossroads, the species from which both Neanderthals and modern humans would eventually emerge. Looking at them, studying their remains, their tools, their living sites, we're not looking at primitives or evolutionary failures. We're looking at successful, intelligent humans who survived and thrived in a world far harsher than anything we've experienced. They were our ancestors, in the most literal sense. The populations in Africa that would eventually become Homo sapiens came from heidelbergensis stock. We carry their genes. Their innovations became our heritage. Their survival made our existence possible. While Homo heidelbergensis dominated Europe and Africa, another human species was still clinging to existence in the far corners of Asia. Homo erectus, the grand old lineage of humanity, the species that had been everywhere, done everything, and survived longer than any other human species in history. But by 400,000 years ago, they were in their twilight years, the last representatives of a once great evolutionary experiment. To understand the significance of Homo erectus still being around at this time, you need to appreciate just how successful they'd been. This was the species that first left Africa nearly 2 million years earlier, the first humans to spread across Asia, reaching as far as Java in Indonesia and probably into China, the first to master fire on a large scale, the first to develop the hand axe, a tool so useful and efficient that it remained essentially unchanged for over 1 million years. Think about that timeline for a moment. Homo erectus first appeared around 1.9 million years ago. They thrived, spread and dominated for nearly 1.5 million years. Modern humans, Homo sapiens, have only existed for about 300,000 years. We're not even a quarter of the way to matching their longevity. If species success is measured in staying power, in the ability to persist across vast spans of time, Homo erectus was the most successful human species ever, but success doesn't mean stasis. Over their immense time range, Homo erectus changed, adapted, evolved in response to different environments. The earliest African Homo erectus, sometimes called Homo ergaster, looked somewhat different from the later Asian populations. They were taller, more lightly built, with slightly larger brains. The Asian populations, especially those in Java, tended to be more robust, with thicker skull bones and more pronounced features. This variation has led to decades of argument among paleoanthropologists. Are all these fossils really the same species? Should Asian Homo erectus be split into separate species like Homo erectus sensu stricto in Java, Homo pekinensis in China, Homo georgicus in Georgia? Or are they all just regional variants of a single, highly variable, widely distributed species? For our purposes, what matters is this: by 400,000 years ago, whatever you want to call them, these populations were no longer the dominant human species. In Africa, they'd been replaced by Homo heidelbergensis. In Europe, if they'd ever reached there in significant numbers, they were long gone. Their last strongholds were in Southeast Asia, particularly in Java, where conditions still favoured their survival. The Javanese environment 400,000 years ago was vastly different from glacial Europe, or even from many parts of Africa. This was tropical Asia, with dense forests, abundant rainfall and a stable, warm climate. No ice sheets advancing and retreating, no brutal winters to survive. Instead, the challenges were different. Dense vegetation that made hunting difficult, high, parasite loads, competition from numerous other predators in the tropical ecosystem, and Homo erectus had adapted to these conditions over hundreds of thousands of years. They knew these landscapes intimately. They knew which plants were edible, which were poisonous. They knew where water could be found during dry seasons. They knew the behaviour patterns of local game animals. This was their home, and they'd been here far longer than humans had been anywhere else on Earth. The fossil evidence from Java tells us they were still around, still surviving, still reproducing. Sites like Ngandong along the Solo River have yielded Homo erectus remains that some researchers date to as recently as 400,000 years ago, though the dating is controversial and some estimates push their survival even later, to perhaps 100,000 years ago or less. But even the conservative estimates put them alive and functioning at the time we're discussing. What we don't know, what the fossils can't tell us directly, is how they were doing. Were these thriving populations still robust and numerous? Or were they remnant groups hanging on in isolated refuges, slowly declining toward extinction? The archaeological evidence suggests something in between. The tools associated with late Homo erectus populations in Java show a remarkable consistency over time. They're still making essentially the same tool, types their ancestors made hundreds of thousands of years earlier. Simple flaked stone tools, choppers, and scrapers. Effective for their purposes, certainly, but not showing the innovation and elaboration we see in Homo heidelbergensis toolkits. This technological conservatism has been interpreted in different ways. Some researchers see it as evidence of cognitive limitations, suggesting that Homo erectus simply weren't capable of the innovation that characterized later human species. Others argue it's evidence of successful adaptation. If your tools work, if they solve the problems you face, why change them? In stable tropical environments, there may have been less pressure to innovate than in the rapidly changing environments of Ice Age Europe. There's probably truth in both interpretations. Brain size in late Homo erectus averaged around 1,000 cubic centimeters, smaller than Homo heidelbergensis, or modern humans, though still much larger than earlier hominins. This suggests some cognitive differences, though again, brain size alone doesn't tell the whole story. But the stability of their tool traditions over such vast time periods does suggest a different relationship with technology than what we see in other human lineages. What's really fascinating, and really tragic, is what we don't know about their final years. Did Homo erectus populations ever encounter Homo heidelbergensis? The geographic ranges barely overlapped, if at all, so probably not. But they might have encountered early Homo sapiens, as modern humans began spreading out of Africa and into Asia. Did they meet? Did they compete? Did they fight? We have hints, tantalizing suggestions that something was happening. The timing of Homo erectus decline roughly correlates with the expansion of other human species into Asia. Correlation isn't causation, of course, but it raises questions. Were they outcompeted for resources? Were they pushed into marginal habitats where survival became increasingly difficult? Or did they simply reach the end of their evolutionary potential, unable to adapt to changing conditions as well as more recently evolved human species? One possibility that's difficult to evaluate is disease. When populations that have been isolated for hundreds of thousands of years suddenly come into contact, disease can be devastating. Modern humans carry pathogens that our ancestors were exposed to, that our immune systems evolved to handle, but Homo erectus, isolated in Asia for millennia, might have had no resistance to African diseases carried by expanding Homo heidelbergensis or early Homo sapiens populations. We see this pattern in recorded history. When European diseases reached Native American populations who had been isolated for thousands of years, the results were catastrophic. Smallpox, measles, influenza, diseases that Europeans had some resistance to, killed Native Americans in staggering numbers. Could something similar have happened to Homo erectus when they encountered other human species carrying unfamiliar pathogens? It's possible, but we have no direct evidence. Diseases don't fossilize. What we do have is the steady thinning of their fossil record. Homo erectus remains become increasingly rare after about 400,000 years ago. The last confirmed specimens date to somewhere between 100,000 and 50,000 years ago, depending on which sites you trust and which dating methods you accept. After that, silence. No more Homo erectus fossils, no archaeological sites that can be definitely attributed to them. They vanish from the record. But they didn't vanish from our DNA. Or at least probably not entirely. Recent genetic analysis has found hints, though not definitive proof, that Homo erectus might have interbred with other human species before going extinct. Some Denisovan DNA, recovered from a finger bone found in Siberia, shows traces of interbreeding with an unknown archaic human population that lived about 1.5 million years ago. That timeline would fit Homo erectus perfectly. If confirmed, this would mean that Homo erectus genes might still be flowing through modern human populations, carried first through Denisovans, then through Denisovan interbreeding with early modern humans, and finally down through the generations to people alive today. A ghost lineage, preserved not in fossils but in fragments of genetic code. The larger question is what Homo erectus survival to 400,000 years ago tells us about human evolution more broadly. For most of the 20th century, scientists thought about human evolution as a ladder, a linear progression from primitive to advanced, with each species representing a rung on the ladder leading inevitably to modern humans. Homo erectus was seen as a middle rung, more advanced than the Australopithecines who came before, but less advanced than the species that came after. But that model is wrong, and Homo erectus persistence helps show us why. Evolution isn't a ladder, it's a bush, with multiple branches growing simultaneously, each adapting to different conditions, each solving survival problems in different ways. Some branches persist for millions of years, others die out quickly. Success and failure are determined not by some abstract measure of advancement, but by the match between a species' capabilities and the environment they're facing. Homo erectus wasn't a failed experiment on the way to something better. They were a successful species in their own right, one that lasted longer and spread farther than any other human species except possibly our own. The fact that they eventually went extinct doesn't diminish their success. All species eventually go extinct. That's the nature of evolution. What matters is what they accomplished while they existed. And what they accomplished was remarkable. They pioneered the human diaspora out of Africa. They proved that humans could survive in radically different environments from the ones we evolved in. They developed sophisticated uses of fire. They created stable, long-lasting tool traditions. They raised children, cared for their injured, formed social bonds. They were, in every meaningful sense, human. By 400,000 years ago, their time was ending. The world was changing in ways that favoured newer human species with larger brains and more flexible behaviours. The glacial cycles were intensifying, creating conditions that required rapid adaptation. In Africa and Europe, Homo heidelbergensis was thriving. In other parts of Asia, other human populations were expanding. The ecological space for Homo erectus was shrinking, but they hadn't given up. In Java, along familiar rivers, in forests their ancestors had known for hundreds of thousands of years, they persisted, hunting the same game, making the same tools, living the same patterns that had sustained them for so long. They were the old guard, the ancient lineage, the species that had been everywhere when the world was young, and somewhere, in ways we can't quite see in the fossil record, they were fading. Not with a bang, but with a slow, gradual decline. Populations getting smaller, territory shrinking. Until finally, sometime between 400,000 and 100,000 years ago, the last Homo erectus died. There would be no monuments, no memorials, no one to remember them except the rocks that preserved a few of their bones. They disappeared, leaving only traces, only fragments, only questions we can't answer about their final days. But for a moment, 400,000 years ago, they were still here, still human, still surviving, still part of the diverse family tree of humanity that once spread across the old world, the last of the Erectus holding on to existence in their tropical refuges, while elsewhere new human species were rising to take their place. To understand the world these human species inhabited, you need to understand just how brutal and unstable the Middle Pleistocene climate really was. This wasn't Earth as we know it, with relatively predictable seasonal cycles and gradual climate variations. This was a planet locked in a cosmic dance with its own orbit, cycling between ice ages and warm periods with a rhythm that shaped continents and destroyed entire ecosystems. The mechanism behind these cycles is called Milankovitch forcing, named after Serbian scientist Milutin Milankovic, who figured out the pattern in the early 20th century. Earth's orbit around the Sun isn't perfectly circular and perfectly stable. It wobbles, it tilts. The shape of the orbit changes over time, shifting between more circular and more elliptical on a cycle that takes about 100,000 years to complete. The tilt of Earth's axis changes on a 41,000-year cycle. The direction of the tilt wobbles on a 26,000-year cycle. Individually, these changes are small, but together they create huge variations in how much sunlight reaches different parts of the planet at different times of year, and that variation is enough to tip Earth's climate between two very different states. For about 90,000 years of each cycle, ice builds. Winters in the northern hemisphere get colder. Snow that falls doesn't completely melt in the summer. It accumulates year after year, century after century, millennium after millennium. The snow compresses into ice. The ice spreads outward, growing into ice sheets thousands of feet thick. From centres in Scandinavia and Canada, glaciers advanced south, covering everything in their path. At the peak of glaciation, ice sheets covered most of Canada, all of Scandinavia, and extended as far south as London, Moscow, and Chicago. Nearly a third of Earth's land surface was under ice, and it wasn't just the ice itself that transformed the landscape. The weight of the ice, in some places more than 2 miles thick, literally pressed the land down, depressing the continental crust hundreds of feet. All that water locked up in ice had to come from somewhere. It came from the oceans. Sea levels during glacial peaks dropped by 300 to 400 feet compared to today. Coastlines extended hundreds of miles beyond their current positions. The English Channel was dry land. The Persian Gulf didn't exist. Indonesia wasn't a collection of islands, but a continuous landmass called Sunderland. A land bridge connected Siberia to Alaska across what's now the Bering Strait. And the climate. The climate was savage. Near the ice sheets, conditions were Arctic. Permafrost extended hundreds of miles beyond the ice edge. Winters brought temperatures that would kill in minutes without fire and shelter. Even in summer, the landscape would have been bleak, cold, dominated by low vegetation adapted to extreme conditions. But here's what's crucial for understanding the human experience of this period. 400,000 years ago wasn't a glacial maximum. It wasn't the coldest point. The world was in transition, partway through one of these 100,000-year cycles. In some regions, it was cold but not brutally frozen. In others, it was relatively warm. The key word is unstable, because the transitions between glacial and interglacial periods didn't happen smoothly. The climate would cool, then suddenly warm for a few decades before cooling again. It would stay cold for thousands of years, then abruptly surge into warmth. These rapid climate fluctuations, happening over timescales of decades rather than millennia, would have been devastating for populations trying to adapt. Imagine you're a Homo heidelbergensis band living in what's now southern France. You've settled near a river where you know the game animals migrate each spring. Your ancestors have used this same campsite for generations. You know every detail of this landscape, where the best tool-making stone can be found, which caves provide the best shelter, where the reindeer herds cross the river. Then, within your lifetime, the climate shifts. The winters get colder. The spring migrations change timing. The reindeer populations decline as the vegetation they depend on withers. Within a generation, the landscape you knew is gone, replaced by something harsher, colder, less productive. You have two choices: adapt or move. This happened over and over throughout the Middle Pleistocene. Populations that had been stable for thousands of years suddenly faced environmental catastrophes that destroyed the resource base they depended on, and they had to respond not over evolutionary time, not over thousands of generations, but immediately, with the knowledge and technology they already possessed. The megafauna made it both easier and harder. Easier because the sheer size of animals during this period meant a single successful hunt could feed a band for weeks. Harder because hunting animals this large was incredibly dangerous. The straight-tusked elephant, Paleoloxodon antiquus, stood up to 13 feet tall at the shoulder and weighed as much as 15 tons. That's larger than modern African elephants, and unlike modern elephants who have been hunted by humans for millennia and have learned to fear us, these animals had no such conditioning. An angry straight-tusked elephant was a mobile mountain of muscle and rage, yet humans hunted them. We find butchered elephant bones at Homo heidelbergensis sites across Europe. At Leringen in Germany, a wooden spear was found embedded in the ribs of a straight-tusked elephant, direct evidence of humans taking on these giants. The spear was made of yew wood, hardened in fire, driven with enough force to penetrate between the ribs and into vital organs. How did they do it? Probably through a combination of technique and opportunism, targeting young animals or sick individuals who couldn't keep up with the herd, using the landscape to their advantage, perhaps driving animals into bogs or over cliffs, working in coordinated groups where some hunters would distract while others attacked from behind or the sides, using fire to panic and direct the animals. But even with all these advantages, it would have been terrifyingly dangerous. One misstep, one hunter out of position, and a charging elephant could kill multiple people in seconds. The mortality rate among hunters must have been significant. We see evidence of healed fractures in Homo heidelbergensis skeletons, broken bones that knitted back together but left the individuals with permanent disabilities. Ribs broken by kicks or goring, leg bones fractured from falls or crushing impacts. These weren't accidents from tripping over roots. These were hunting injuries, the cost of being apex predators in a world full of megafauna. The woolly rhinoceros, Chelodonta antiquitatis, was another major prey animal, though they wouldn't reach their peak diversity until later in the Pleistocene. But their ancestors, the Merck's rhinoceros and other species, were present 400,000 years ago. These were animals weighing 3 to 4 tons, with thick hides tough enough to turn stone weapons, and horns that could disembowel with a single thrust. Aggressive, unpredictable, and powerful enough to shrug off wounds that would kill smaller animals. The cave bear, Ursus spelaeus, wasn't primarily a prey animal, but a competitor. These bears stood over 10 feet tall when upright and weighed up to 1/500 pounds. They were omnivores, but massive omnivores who needed the same cave shelters that humans favoured. Evidence from some caves shows alternating layers of bear and human occupation, suggesting they took turns using the same sites, each species moving in when the other left. But there must have been confrontations. A band of humans arriving at a cave in winter to find it occupied by a hibernating bear family. A bear emerging from hibernation to find humans have claimed its territory. These encounters wouldn't have ended peacefully. The fact that humans eventually dominated the cave system suggests they won most of these contests, but the cost in human lives must have been significant. Then there were the predators actively hunting humans: cave lions, Panthera spelaea, larger than modern lions and possibly social hunters, cave hyenas, Crocuta spelaea, intelligent pack hunters who could crack open bones and might have competed directly with humans for carcasses, wolves, the ancestors of modern wolves but larger, and adapted for hunting megafauna. Humans weren't at the top of the food chain by default. They fought their way there over thousands of generations through intelligence and cooperation and weapons technology. But they paid a price. Every generation lost people to predators, to hunting accidents, to the dangers of a world that was actively trying to kill them. The vegetation was changing too, driven by the climate cycles. During warmer periods, forests dominated. Oak, beech, pine, creating dense, woodland environments. During colder periods, the forest retreated, replaced by grasslands and tundra. This wasn't gradual. Core samples from lake beds show that forests could be replaced by grassland within a few human generations, driven by rapid climate shifts. And each vegetation change meant changes in the animal populations. Some species thrived in forests, others in open grasslands. As the landscape transformed, so did the hunting opportunities. Knowledge that had been valid for generations could become obsolete within a lifetime. The animals your parents hunted might no longer exist in your territory. The plants your grandparents gathered might have died out, replaced by different species. This constant environmental churning required cognitive flexibility that might not have been necessary in more stable periods. You couldn't just learn the skills your parents taught and apply them unchanged throughout your life. You had to adapt, improvise, figure out how to apply old knowledge to new situations or develop entirely new strategies. Fire became crucial not just for warmth, but for survival. During the coldest periods, humans in Europe simply couldn't survive without it. The archaeological evidence shows increasing sophistication in fire use throughout the Middle Pleistocene. Early humans might have relied on capturing natural fire started by lightning. By 400,000 years ago, there's strong evidence for fire creation on demand. The techniques probably varied, striking sparks from flint into tinder, using friction between wooden components to create heat. Once created, fire had to be maintained constantly. Letting your fire go out during winter could be a death sentence. Someone had to keep watch, feeding fuel, protecting the flames from wind and rain. Fire also provided protection from predators. Most large carnivores are afraid of fire and won't approach an active flame. A fire at the mouth of a cave could turn it from a dangerous sleeping spot into a safe refuge. Fire extended the usable hours of the day, allowing activities to continue after sunset. And crucially, fire made more food accessible through cooking. Cooking isn't just about taste, it's about nutrition and safety. Cooking kills parasites and bacteria that could cause disease. It makes tough foods easier to chew and digest, allowing humans to extract more calories from the same amount of food. It can render toxic plants edible by breaking down harmful compounds. Some researchers argue that cooking was so important to human evolution that it drove brain expansion. Larger brains require more energy, and cooking made more energy available from the same food sources. The competition for resources between different human species adds another dimension to this environmental pressure. We don't know how often Homo heidelbergensis and Homo erectus encountered each other, if ever. Their ranges barely overlapped, but even without direct contact they were competing for fundamentally similar resources: large-game animals, water sources, caves suitable for shelter, stone suitable for tool-making. In regions where different human species did coexist, this competition must have been intense. Not necessarily violent, though that was probably part of it, but competitive in the evolutionary sense. Which species could extract more resources from the same landscape? Which species could survive environmental fluctuations better? Which species could innovate new solutions when old strategies failed? The archaeological record hints at this competition through absence. We find Homo heidelbergensis sites in Europe, but very few sites that might be Homo erectus. We find early Neanderthal populations beginning to emerge in the harsher northern regions, areas where the cold-adapted traits they were evolving would have given them advantages. Different species finding different niches, different solutions, different ways to survive in the same unstable world. And underlying everything, the ice. Always the ice. Growing during cold periods, retreating during warm ones, reshaping continents, redirecting rivers, determining which lands were habitable and which were locked under miles of frozen water. The ice was the great driver, the force that made everything else happen. It controlled sea levels, determined climate patterns, shaped the distribution of vegetation and animals. Humans living 400,000 years ago couldn't have understood the forces driving these changes. They didn't know about orbital mechanics or ice sheet dynamics, but they experienced the consequences directly. They saw the world transform around them. They watched familiar landscapes become alien. They adapted, or they died, and most species died. Of all the megafauna that dominated the Middle Pleistocene, most would be extinct within a few 100,000 years. Of all the human species competing for survival, only one would ultimately succeed. But 400,000 years ago, that outcome was still unwritten. The world was full of possibility and danger, of ice advancing and retreating, of megafauna herds and predator packs, of different human species all struggling to survive in a planet that refused to stay still long enough for anyone to get comfortable. Survival 400,000 years ago wasn't about individual heroics or moments of genius. It was about the accumulated knowledge of generations, about learned skills practiced until they became second nature, about cooperation and shared information. It was about doing 1,000 things correctly every single day, because any one of them done wrong could kill you. Let's start with something basic: water. You need it constantly. A human can survive weeks without food, but only days without water. In the Middle Pleistocene, finding clean water wasn't as simple as turning a tap. Rivers and streams were obvious sources, but they came with risks. Predators knew prey animals needed water and waited near sources. Other human groups might claim prime water sources as territory. During droughts, water could become scarce enough that access to reliable sources meant life or death. Homo heidelbergensis populations had to develop intimate knowledge of their territories. They needed to know not just where water was during the wet season, but where it persisted during dry periods. Which springs flowed year-round, which rock formations trapped water in pools, where to dig to reach underground water tables. This wasn't written knowledge. This was learned through experience and passed down through generations, probably through a combination of direct teaching and following the knowledge keepers of the group. Toolmaking was another survival skill that required years of learning and practice. We tend to think of stone tools as simple, primitive technology, but creating an effective hand axe or spear point from a raw piece of flint requires understanding material properties, spatial reasoning, and fine motor control that takes years to develop. The process started with finding the right stone. Not all rock works for tools. You need stone that fractures in predictable ways when struck, creating sharp edges. Flint, obsidian, chert, certain types of quartzite. These materials had to be located, often requiring travel to specific quarries or river gravels where they could be found. Some groups controlled access to the best stone sources, creating trade relationships or conflicts over access. Once you had suitable stone, you needed to understand how to work it. Strike too hard, the stone shatters uselessly. Strike too soft, nothing happens. The angle of the strike matters. The type of hammer matters. Using stone hammer gives different results than using bone or antler. Different techniques create different tool types. The Acheulean hand axe, the signature tool of Homo heidelbergensis, required removing flakes from both sides of a stone core, carefully shaping it into a symmetrical teardrop form with a sharp edge around most of its perimeter. Master toolmakers could create a hand axe in 15 to 20 minutes, but reaching that level of skill required years of practice. Young humans would have spent hours watching skilled adults, learning by observation and imitation. They would have practiced on lower quality stone, making mistakes, slowly developing the muscle memory and spatial understanding needed to create effective tools. And tools weren't one size fits all. Different tasks required different implements. Large hand axes for butchering big game, smaller flake tools for delicate cutting, scrapers for processing hides, pointed tools for piercing. A competent hunter would have carried multiple tool types, knowing which to use when. Then there were the wooden tools, which rarely survived but were probably even more common than stone. Digging sticks for extracting roots and tubers, spears for hunting, both thrusting spears for close combat and throwing spears for distance attacks, clubs and staffs for defense and killing wounded animals, possibly containers woven from plant fibers, though these almost never preserve in the archaeological record. The schoeningen spears we discussed earlier weren't just sharpened sticks. They were engineered weapons. The maker had to select the right wood, spruce in this case, for its combination of strength and flexibility. The wood had to be seasoned, dried to the right moisture content. The spear had to be shaped along its entire length, creating the proper taper and balance point. The tip had to be hardened, probably by carefully charring it in fire to drive out moisture and compress the wood fibers. Creating one of these spears probably took days of careful work, and a hunter might need multiple spears for a single hunt, since spears could break on impact or be lost if wounded animals fled. This meant constant tool production and maintenance was necessary. Time that could have been spent hunting or gathering had to be invested in creating and repairing the tools that made hunting and gathering possible. Hunting strategies varied by terrain, by prey animal, by season, and probably by the specific knowledge and preferences of different groups. But some patterns emerge from the archaeological evidence. Ambush hunting was probably common. Instead of tracking animals across open ground, hunters would position themselves along known migration routes or near water sources animals had to visit. They would wait, sometimes for hours, for the right moment when an animal was vulnerable. A young individual separated from the herd, an older animal that couldn't keep up, an animal focused on drinking and not watching for threats. The actual kill, despite all the Hollywood imagery of dramatic spear throws and heroic struggles, was probably as quick and efficient as possible. The goal wasn't to give the animal a sporting chance. The goal was to bring it down with minimum risk to the hunters. Multiple spears thrown simultaneously from different angles, overwhelming the animal's ability to defend itself or flee. Targeting vital areas, lungs and heart, wounds that would cause rapid death from blood loss or suffocation. For very large animals like elephants, the strategy might have been different. Direct confrontation with a healthy adult elephant would have been suicidal. Instead, hunters probably targeted individuals that were already compromised, animals sick or injured, young elephants not yet full grown, possibly using fire to drive animals into terrain that limited their mobility, bogs or steep ravines where their size became a disadvantage. Once an animal was down, the work really began. A dead elephant represented thousands of pounds of meat, but it also represented a race against time and competition from scavengers. Large carnivores could smell blood from miles away. Hyena packs would have moved in quickly. Birds of prey would circle overhead. The hunters had to process the carcass as rapidly as possible, removing the most valuable parts before they were driven off or the meat spoiled. Butchery marks on bones from Middle Pleistocene sites show systematic, efficient processing. The hunters knew anatomy, knew how to efficiently remove muscles, knew which parts to take first. Tongues and organs were typically removed quickly as they spoil fast but are nutritious. Major muscle groups came next. Bones were broken open for marrow, which is rich in fat and calories. Hides might be removed for use as clothing or shelter materials, though evidence for this is indirect since hides rarely preserve. Some of the meat was probably consumed on site, but much of it would have been transported back to a home base, a cave or rock shelter, where the rest of the group waited. This required planning and coordination. Who carries what? How do you transport hundreds of pounds of meat across potentially difficult terrain. Do you post guards to watch for predators while others make multiple trips? The distribution of meat within the group also required social rules. Did everyone get equal shares? Did successful hunters get more? Were certain individuals, perhaps leaders or the elderly who could no longer hunt, given priority? These decisions would have been made according to social norms that we can only guess at from modern hunter-gatherer societies. Plant gathering was probably just as important as hunting, possibly more so for reliable caloric intake. Meat from a successful hunt could feed a group for days, but hunts could fail. Plants were more predictable, more easily gathered, lower risk. But plant gathering required extensive knowledge. Which plants are edible? Which are poisonous? Which parts of a plant can you eat and which are toxic? When are different plants available? Where do they grow? Some plants are nutritious only at certain times of year. Some require processing to be edible. Some can only be safely eaten after cooking. This knowledge varied by region and had to be learned and maintained across generations. A Homo heidelbergensis band migrating into new territory would have faced significant challenges figuring out which local plants were safe. Experimentation would have been dangerous. Watching what animals ate might have provided clues, but animals can safely eat things toxic to humans. The seasonal round, the annual cycle of moving between different resource patches as they became available, required planning and memory. In spring, you move to the river crossing where the reindeer migrate. In summer, you move to high meadows where certain plants can be gathered. In fall, you move to forests where nuts and fruits ripen. In winter, you return to the best cave shelters. Each of these moves had to be timed correctly. Arrive too early and the resources aren't ready. Arrive too late and other groups might have already exploited them. And you had to balance immediate needs against future planning. Do you consume all available food now, or do you preserve some for leaner times? Fire management was a constant occupation. Once you had fire, you couldn't let it go out. Maintaining embers through wet weather, through moves between campsites, through the night when everyone needed to sleep, this required designated firekeepers, probably a role that rotated through the group. Creating fire from scratch was possible but difficult. The bow drill technique, where you rotate a wooden spindle rapidly against a wooden base to create friction heat, works but requires skill and the right materials. Striking sparks from iron pyrite against flint can ignite tinder, but you need to know where to find iron pyrite and how to prepare tinder that will catch from a spark. More likely, groups tried very hard never to let their fire go completely out. Embers could be kept alive for days in carefully tended hearths, banked with ash to retain heat. When moving camp, embers could be transported in containers, possibly hollowed sections of wood filled with slow-burning material. The hearth itself was often an engineered structure, not just a random pile of burning wood. Rocks might be arranged to reflect heat toward the living area. The location would be chosen to minimize smoke blowing into the shelter while maximizing heat distribution. Different woods would be selected for different purposes. Some burn hot and fast for cooking, others burn slow and steady for overnight warmth. Some create less smoke, important in confined spaces. Shelter construction shows remarkable sophistication even 400,000 years ago. While caves and rock overhangs were preferred when available, they weren't always in the right locations. Sometimes groups had to construct their own shelters from available materials. At Terre Amata in France, archaeologists found evidence of built structures from this period, post holes where wooden supports had been placed, arrangements of stones that appear to have been foundations or weights, holding down hide or brush walls. These weren't elaborate buildings, but they were deliberate constructions designed to provide protection from weather and predators. The shelters were temporary, probably rebuilt each year as groups returned to favoured locations. But their very existence shows planning and engineering knowledge, understanding which woods made good structural supports, knowing how to waterproof a roof using hides or layered vegetation, creating windbreaks and heat-retaining designs that made shelter functional even in harsh weather. Defense against predators was another constant concern. Humans might have been apex predators, but they were also vulnerable, especially children and injured individuals. Caves provided natural protection, but the entrance had to be guarded. Fire helped, but predators could learn to approach from upwind where humans wouldn't smell them coming. Some form of night watch was probably standard, taking turns staying awake, keeping the fire fed, listening for sounds of approaching danger. During the day, when groups split up to hunt or gather, individuals would have needed to stay alert, watching for threats, ready to call out warnings or flee to safety. Social cooperation wasn't optional, it was essential for survival. A lone human in the Middle Pleistocene wouldn't last long. Injury or illness that prevented you from contributing to the group could be a death sentence. This created strong selective pressure for altruism and mutual support, but also for ostracism of individuals who couldn't or wouldn't contribute. The evidence from the cima de los huesos of individuals with significant disabilities surviving to adulthood shows that Homo heidelbergensis groups did care for their vulnerable members. But this care probably had limits. Resources were scarce. Supporting someone who couldn't contribute meant less for everyone else. Difficult decisions would have had to be made about who received care and who didn't. Conflict between groups was probably common, though direct evidence is scarce. Competition for prime territories, for access to water sources and game animals, for control of toolstone quarries, all of this could lead to violence. We find some skeletal remains from this period showing evidence of healed injuries that might have come from interpersonal violence, though proving this is difficult. But cooperation between groups might also have occurred. Exchange of information about distant territories, trade of tool materials or other resources, possibly even exchange of individuals to prevent inbreeding in small populations, though this is speculation based on modern hunter-gatherer practices. What's clear is that survival required constant attention, constant work, constant application of learned skills. There was no safety net, no stored surplus to fall back on during hard times. Every day required successfully finding food and water, maintaining fire and shelter, avoiding predators and environmental hazards, all while managing the social dynamics of group living. The humans who survived to pass on their genes were the ones who mastered this complex suite of skills, who learned from their elders, who paid attention to details, who cooperated when necessary and competed when required, who made the right decisions more often than wrong ones, who were in short extraordinarily good at the art of staying alive in a world that was constantly trying to kill them. The hardest thing to understand about humans from 400,000 years ago isn't their tools or their bodies, it's their minds. What were they thinking? How did they experience the world? Were they conscious in the way we understand consciousness? Did they have language? Did they tell stories, make jokes, feel wonder at the stars? These questions are nearly impossible to answer with certainty because minds don't fossilize. We can measure skull capacity and estimate brain size, but that tells us almost nothing about cognition, about how those brains processed information or what kind of thoughts they generated. We can examine the things they made and the places they lived, but interpreting those artifacts requires massive assumptions about intent and meaning. Yet there are hints, tantalizing suggestions scattered through the archaeological record that point to cognitive abilities we might recognize as fundamentally human. Let's examine the evidence and see what it might tell us. Start with ochre. Red ochre, an iron oxide mineral that creates vivid red and yellow pigments, shows up at Homo heidelbergensis sites across Africa and Europe. At first glance, this seems unremarkable. Maybe they used it as a hide preservative, a practical application with no symbolic meaning. But the distribution is curious. Ochre appears at sites hundreds of miles from the nearest natural deposits, meaning it was deliberately transported. Pieces show evidence of scraping and grinding, suggesting it was being processed, reduced to powder. At some sites, the ochre has been heated, which intensifies its colour and changes its properties. This isn't something you do by accident. This is deliberate modification requiring an understanding that fire can transform materials, that the processed ochre is somehow more desirable than the raw mineral. Why would Homo heidelbergensis invest time and effort in obtaining, transporting and processing a material that has no obvious functional value? The most parsimonious explanation is that they valued it for its appearance. They wanted the colour red. And wanting something for aesthetic reasons rather than practical ones suggests a cognitive leap. It suggests they could conceive of abstract value, that something could be desirable not because it helped you survive directly, but because it appealed to some inner sense of what was pleasing or significant. Some researchers go further, suggesting the ochre was used for body decoration, painting faces or bodies with distinctive patterns. If true, this would indicate even more sophisticated thinking. Body decoration is fundamentally symbolic. It communicates identity, group membership, status, age, or ritual state. It requires you to understand that others will see the decoration and interpret it, that you can deliberately send messages through visual signals, but we have no direct evidence of this, no preserved body paint on skeletal remains, no clear depictions showing how ochre might have been used. We're inferring symbolic behaviour from the presence of a coloured mineral, which is admittedly a stretch. Yet the alternative, that they transported ochre for hundreds of miles for purely practical purposes, seems even less plausible. Then there's the question of spatial organisation. When you examine Middle Pleistocene living sites carefully, patterns emerge. Not random scatters of debris, but structured use of space. Hearths aren't placed randomly, but in specific locations within shelters, usually positioned to maximise heat distribution while minimising smoke accumulation. Tool-making areas are often separate from sleeping areas. Butchery sites are typically outside the main living space, probably to avoid attracting predators with the smell of blood. This spatial organisation suggests planning and abstract thinking, the ability to conceive of a space not as it currently is, but as you want it to be. To imagine the flow of smoke before you build a fire, to anticipate how debris will accumulate and position your activities accordingly. These might seem like simple organisational skills, but they require mental modelling, the ability to run simulations in your head of how things will work out. At some sites, there's evidence of maintenance activities, deliberate cleaning, removing debris from living areas, renewing hearth structures. This goes beyond momentary convenience. This is caring about the state of your living space as an ongoing concern, maintaining it for future use. It suggests a conception of the future, an understanding that you'll return to this place and want it to be functional. The Cima de los Huesos site in Spain, the Pit of Bones, raises even more intriguing questions about Homo heidelbergensis cognition. Remember, this is the site where 28 individuals were found at the bottom of a deep cave shaft, along with a single beautiful hand axe made of exotic pink quartz. The standard interpretation is that this represents deliberate disposal of the dead, possibly the earliest evidence of burial practices. But think about what that means cognitively. Burial implies concern for the dead beyond practical considerations. If you're just trying to avoid having corpses near your living area, you don't go through the effort of carrying them deep into a cave system and depositing them in a specific pit. You just leave them away from camp and let scavengers handle them. Deliberate burial suggests the dead matter to you emotionally, that you're maintaining some kind of relationship with them even after death. Some researchers argue the pink quartz hand axe is grave goods, an offering placed deliberately with the dead. If true, this would suggest belief in an afterlife, or at least some notion that the dead might need tools or that placing valuable objects with them serves some purpose. But we can't be certain. The individuals might have fallen into the pit accidentally over many years, a natural trap rather than a burial site. The hand axe might have been dropped by someone exploring the cave, unrelated to the human remains. The evidence is suggestive but not conclusive. What about language? This is perhaps the most debated question in all of paleoanthropology. Did Homo heidelbergensis have language in the way we understand it? Grammar, syntax, the ability to express complex abstract ideas through vocal symbols? The anatomical evidence is mixed. The hyoid bone, which anchors the tongue and is crucial for speech, has been found in Homo heidelbergensis specimens and resembles the modern human hyoid. The base of the skull shows features suggesting the larynx was positioned similarly to ours, allowing for a similar range of vocalizations. The thoracic vertebrae, the bones of the upper spine, show adaptations that some researchers interpret as necessary for the fine breath control required for speech, but anatomy only shows capability, not use. Parrots have the physical equipment for complex vocalizations, but don't use them for language. Neanderthals, who came later and had even more human-like speech anatomy, might not have had fully developed language despite their physical capability. What we can say with more confidence is that Homo heidelbergensis had sophisticated communication. Teaching toolmaking requires demonstration, and probably some form of verbal instruction. Coordinating group hunts requires communication about plans and roles. Maintaining social relationships in groups of 20 or 30 individuals requires being able to convey complex social information. Whether this was true language with recursive grammar and the ability to discuss abstract concepts, or a more limited proto-language combining gestures, vocalizations, and context, remains unknown, but they were definitely communicating in ways more sophisticated than any non-human primate. The transmission of knowledge across generations is itself evidence of cognitive sophistication. stone tool-making traditions remained stable for hundreds of thousands of years across vast geographic ranges. This isn't genetic. This is cultural transmission, learned behavior passed from experienced individuals to novices through teaching and observation. Consider what this means. An individual living in France 400,000 years ago was making hand axes using techniques virtually identical to those used by their ancestors tens of thousands of years earlier and by populations hundreds of miles away. This stability across time and space requires active teaching, a deliberate effort to ensure the young learn correctly. It requires patience from teachers and motivation from learners. It suggests value placed on tradition and correct technique. But alongside this conservatism, there's evidence of innovation. The Schoningen spears represent a technological advance over simple sharpened sticks. The use of fire was becoming more sophisticated over time. Some sites show novel solutions to local challenges. This balance between tradition and innovation is characteristically human, respecting what works while remaining open to improvements. There's also evidence of forward planning extending beyond the immediate moment. At some sites, archaeologists have found caches of tool-making stone, raw materials transported from quarries and stored for future use. This requires imagining future needs and taking action in the present to prepare for them. It's a form of mental time travel, projecting yourself into future scenarios and planning accordingly. Seasonal movements between different resource patches also require planning and memory. Remembering that a certain plant ripens in a certain location at a certain time of year, then organising a move to arrive there at the right moment, anticipating that game animals will follow specific migration routes and positioning yourself to intercept them. This isn't instinct. This is learned knowledge about temporal and spatial patterns, actively maintained and applied. The care shown to injured and disabled group members, which we discussed earlier, has cognitive implications. It requires empathy, the ability to understand that others experience pain and suffering. It requires altruism, willingness to expend effort for individuals who can't immediately reciprocate. It might even suggest a moral sense, a feeling that care is the right thing to do regardless of practical benefits. Some researchers have looked for evidence of artistic expression, of deliberate creation of objects or marks for purely aesthetic or symbolic reasons. The evidence is minimal and controversial. A few stones with scratched lines that might be deliberate markings or might be random damage. Pieces of bone with patterns of cuts that might represent counting or recording, but might be butchery marks. The problem with identifying art from this period is that we're looking for something that probably didn't exist yet in forms we'd recognise. If Homo heidelbergensis had artistic impulses, they might have expressed them in materials that don't preserve. Body painting, as we discussed, wooden objects carved with patterns, songs or rhythmic vocalizations, dance or gestural performances. None of these would leave archaeological traces, or maybe they simply didn't have art in any form we'd recognise. Maybe their aesthetic sense was satisfied by creating well-made tools, by the elegance of a perfectly balanced spear or the symmetry of a hand axe. Maybe they appreciated natural beauty, sunsets and stars and flowing water, without feeling compelled to recreate it. What we can say is that Homo heidelbergensis minds were different from ours in some ways, but probably similar in others. They could solve complex problems, they could learn and teach, they could plan and remember, they could cooperate and communicate. They experienced emotions, formed attachments, felt fear and possibly grief. They existed as conscious beings in the world, perceiving and interacting with it in ways that were probably not entirely alien to how we experience consciousness. But there were likely differences too. Modern human cognition is characterized by what some researchers call cognitive fluidity, the ability to combine knowledge from different domains in novel ways, to use social reasoning to solve technical problems, or technical knowledge to navigate social situations, to create analogies and metaphors that span conceptual categories. It's possible that Homo heidelbergensis cognition was more modular, with different types of thinking handled by different mental systems that didn't communicate as freely. Their technical intelligence might have been highly developed while their social intelligence or their ability to think symbolically remained more limited. Or maybe we're completely wrong about this. Maybe they had cognitive abilities we can't even imagine because they've left no trace in the archaeological record. Maybe they had rich internal lives, complex beliefs about the world, sophisticated social reasoning that we simply can't detect from stone tools and butchered bones? The honest answer is, we don't know. We're trying to reconstruct minds from the indirect traces they left behind. It's like trying to understand someone's personality by looking at their trash. Possible to get some insights, but impossible to capture the full complexity of their inner experience. What we can say with confidence is that these were not simple creatures operating on instinct. These were thinking beings facing a complex world and developing sophisticated strategies to navigate it. Their minds were capable of abstraction, planning, learning, teaching, and social coordination. Whether they were capable of symbolic thought, of language, of art, of spirituality, these remain open questions. But they were human minds, different from ours in degree and possibly in kind, but recognizable as minds, engaged in the fundamentally human project of making sense of the world and surviving in it. Minds in transition, perhaps, evolving towards something more like modern human cognition, but not quite there yet. Minds that remind us that human consciousness itself has a history, that the way we think is the product of millions of years of evolution, and that our ancestors thought in ways both familiar and strange. Here's a question that haunts anyone who studies this period. What happened when different human species encountered each other? When a band of Homo heidelbergensis, tracking game through a valley, suddenly encountered a group of Homo erectus doing the same thing, what happened next? We like to think we'd know the answer to this. We have plenty of examples from recorded history of what happens when different human groups meet. Sometimes trade and cooperation, sometimes conflict and violence, sometimes a mix of both, changing depending on circumstances and the individuals involved. But those are all interactions between members of the same species, Homo sapiens. What happens when the meeting is between actually different species? We don't have good modern analogies. The closest might be encounters between modern humans and Neanderthals, which we know from genetic evidence definitely happened and involved interbreeding. But those encounters occurred much later, maybe 100,000 years ago at the earliest, well after the period we're discussing. For 400,000 years ago, we have to rely on inference, on theoretical models, on the sparse archaeological evidence, and on what we know about animal behavior when different species compete for the same resources. First, let's establish what we know for certain. Multiple human species existed at the same time. Homo heidelbergensis in Europe and Africa, Homo erectus in parts of Asia, possibly other species or populations we haven't identified yet. These species had overlapping ecological niches. They all hunted large game, used fire, made stone tools, occupied caves and rock shelters. They all needed water, tool-making stone, and prime hunting territories. Given this overlap, encounters were probably inevitable in regions where their ranges came into contact. And we do have a few archaeological sites that might show evidence of this. The evidence is frustratingly ambiguous, but let's examine what we have. Some sites in Europe show layers of occupation by different human species, though rarely overlapping directly in time. A cave might have Homo heidelbergensis remains and tools in upper layers, with older layers below containing different tool types that might indicate earlier occupation by a different species. This suggests sequential use of the same sites, which raises interesting questions. Did later arrivals know about previous occupants? Did they find tools or remains left by earlier groups and recognize them as the work of other humans? Or did they simply stumble upon caves that happened to be good shelter, unaware that others had used them before? More intriguing are sites where different tool traditions appear in the same temporal layers. At a few locations in Europe and Asia, archaeologists have found what appear to be two distinct tool-making styles in deposits of the same age. Some researchers interpret this as evidence of different human populations or species living in close proximity, possibly even interacting. The problem is proving this interpretation. Tool styles can vary within a single species, even within a single population. What looks like evidence of two different species might just be individual variation, or different activities requiring different tool types, or changes in available raw materials leading to different manufacturing techniques. But let's assume for a moment that encounters did happen. What might they have looked like? The least dramatic scenario is avoidance, different groups simply steering clear of each other, using spatial or temporal separation to minimize contact. You hunt in this valley during the summer, we'll hunt in that one. You use this water source in the morning, we'll use it in the evening. This kind of mutual avoidance is common in territorial animals, and could have worked for human species with overlapping ranges. Avoidance would have required some form of recognition, the ability to identify members of other species as different, as not us, and therefore to be avoided. This might have been obvious from physical appearance. Homo heidelbergensis and Homo erectus had noticeably different body builds and facial features. Even at a distance, you might be able to tell them apart. But recognition could also have come from cultural markers. Different groups might have made different types of fires, used different camping arrangements, left different patterns of debris. Experienced hunters tracking other humans could have learned to distinguish these signs and used them to avoid encounters. The advantage of avoidance is that it minimizes conflict. The disadvantage is that it potentially wastes resources. If prime hunting territory or water sources are being avoided because another group uses them, you're restricting your own access to necessary resources. The next step up would be territorial conflict, direct confrontation over access to limited resources. This could range from aggressive displays meant to intimidate without actual violence to outright combat with lethal intent. We have very little evidence for violence between different human species, which is interesting in itself. If conflicts were common, we'd expect to find skeletal remains showing trauma from weapons. Skulls fractured by clubs, bones pierced by spears, patterns of injury suggesting organized violence. Such evidence does exist from later periods in human history, showing that Homo sapiens definitely engaged in warfare. But from the Middle Pleistocene, it's almost entirely absent. This could mean conflicts were rare, or it could mean they were common but rarely left identifiable traces. Most violent encounters might not have resulted in immediate death, but in injuries that killed later through infection or blood loss. Bodies might have been left where they fell rather than buried, leading to poor preservation. Or maybe violence happened primarily through methods that don't leave skeletal evidence, like strangulation or drowning. There's also the possibility of one-sided violence. If one species was significantly stronger or better armed, encounters might have been more like predation than warfare, the stronger species simply killing or driving off the weaker when they met. This is grim to consider, but it's not implausible. Modern humans have certainly shown a capacity for this kind of violence against groups we perceive as other. But alongside the potential for conflict, there's also potential for cooperation. We know from modern hunter-gatherer societies that different groups sometimes cooperate, sharing information about resource availability, coming together for large-scale hunts or social gatherings, even intermarrying to maintain genetic diversity and forge alliances. Could different human species have done this? The question immediately raises issues of compatibility. Could they communicate effectively enough to cooperate? Did they recognize each other as similar enough to trust? The genetic evidence from later periods suggests that some interbreeding occurred between human species. Modern humans carry Neanderthal DNA, and some populations carry Denisovan DNA. This proves that at least sometimes members of different species were interacting intimately enough to produce offspring. Whether this interbreeding was the result of consensual relationships, forced encounters, or something in between is impossible to determine. But it does prove that different species could produce viable offspring, which suggests they weren't as reproductively isolated as, say, horses and donkeys, whose offspring are usually sterile. For 400,000 years ago specifically, we don't have genetic evidence of interbreeding because we haven't recovered ancient DNA from specimens of that age. DNA degrades over time, and recovering usable genetic material from fossils older than about 500,000 years is extraordinarily difficult, so we can't definitively say whether Homo heidelbergensis and Homo erectus ever interbred. But anatomically, they were probably compatible. Both species had similar body plans, similar developmental patterns, similar gestation periods. If they encountered each other and social circumstances allowed it, interbreeding might have been possible. One scenario that's worth considering is peaceful coexistence in different niches. Maybe different species weren't in direct competition because they specialized in different resources or different hunting strategies. Homo heidelbergensis, with their sophisticated throwing spears and coordinated group hunts, might have focused on large, dangerous game. Homo erectus might have relied more on persistence hunting of smaller animals or more intensive gathering of plant resources. If their subsistence strategies were different enough, they might have been able to coexist in the same general region without excessive conflict, like lions and leopards in Africa, which compete for some resources but occupy slightly different niches and generally avoid direct conflict. Another possibility is that encounters were simply rare enough not to matter much. If human population densities were low and different species occupied mostly separate regions, they might have encountered each other only occasionally. Rare enough that most individuals would never personally meet a member of a different species, making them more mythical than real in their understanding of the world. There's a romantic notion that sometimes appears in popular accounts of human evolution. The idea that different human species might have learned from each other, that a Homo heidelbergensis group might have observed Homo erectus using fire in a certain way and copied the technique, or vice versa. Cultural exchange between species. There's almost no evidence for this, and it's probably wishful thinking. Cultural exchange requires a level of trust and communication that seems unlikely between species that would have appeared significantly different from each other and might have been in competition for resources. But the complete absence of evidence doesn't make it impossible. Maybe it happened rarely, in unusual circumstances. A young individual from one species orphaned and adopted by another. A chance peaceful encounter where demonstration of useful knowledge created mutual benefit. We can imagine scenarios, but we can't prove they occurred. What we can say is that the coexistence of multiple human species created a more complex social landscape than we experience today. Modern humans are used to being the only human species. Every other human we meet is fundamentally like us, capable of the same kind of communication and cooperation, part of the same species despite superficial differences in appearance. But 400,000 years ago, you might encounter humans who were genuinely, fundamentally different. Not just different cultures or different appearances, but different species with potentially different cognitive capabilities, different communication systems, different understandings of the world. How this affected the psychology of these species is impossible to know. Did Homo heidelbergensis have a concept of us versus them that included species-level distinctions? Did they recognize Homo erectus as human but not quite us? Or did they simply see them as dangerous competitors like bears or lions to be avoided or killed? Did they wonder about these others? Did they tell stories about encounters with the strange humans who looked different and acted different? Did those stories become myths, explanations for the diversity they saw in the world? These are questions we cannot answer with archaeology alone. We can speculate based on modern animal behavior, on what we know about later human interactions, on theoretical models of competition and coexistence. But the truth is lost to time. What we do know is that, eventually, most of these species went extinct. Homo erectus disappeared, probably sometime between 400,000 and 100,000 years ago, depending on which populations you consider. Homo heidelbergensis transformed into descendant species, Neanderthals in Europe and early Homo sapiens in Africa, and ceased to exist as a distinct form. Whether encounters between different species contributed to these extinctions is unknown. Maybe competition from better adapted species drove Homo erectus into marginal habitats where they couldn't survive. Maybe disease transmission between species played a role. Maybe it was pure environmental change, with some species better suited to new conditions than others. Or maybe encounters between species were largely irrelevant to their ultimate fates. Maybe each species was on its own evolutionary trajectory, shaped primarily by environmental pressures and internal population dynamics, with interactions between species being just occasional footnotes in their larger stories. The frustration of not knowing is immense. This is one of the most interesting questions in all of human evolution. How did our ancestors interact with other human species? What did they think of each other? How did these interactions shape both their evolution and their extinction? But unless we develop new methods for extracting information from the archaeological record, or unless we get incredibly lucky with new fossil discoveries that preserve evidence of encounters, these questions will remain unanswered. We're left with speculation and imagination, trying to reconstruct social dynamics from stone tools and fragmentary bones, knowing that the most interesting parts of the story have been lost forever. What we can hold on to is the certainty that these encounters happened. Multiple human species shared the Earth. They must have met, at least occasionally. They must have made decisions about how to respond to these meetings, and those decisions, whatever they were, played some role in shaping the future of humanity, even if we can't see exactly how. While Homo erectus faded in Asia and populations competed across Africa, something remarkable was happening in Europe. Populations of Homo heidelbergensis trapped by advancing glaciers were transforming into something new. They were becoming Neanderthals, and 400,000 years ago we can catch this transformation in progress. This wasn't a sudden change, some dramatic mutation that instantly created a new species. Evolution doesn't work that way. This was a gradual process taking tens of thousands of years as populations adapted to the unique pressures of Ice Age Europe, and the Cima de los Huesos site in Spain gives us a precious window into this transformation. Those 28 individuals we've discussed, found at the bottom of the cave shaft, are dated to approximately 430,000 years ago. When researchers first examined the fossils, they noticed something interesting. These weren't quite typical Homo heidelbergensis. They showed features, subtle ones, that pointed toward what would eventually become classic Neanderthal anatomy. The skulls were more rounded at the back than typical heidelbergensis. The face showed early signs of the midfacial projection that would become a distinctive Neanderthal trait. The teeth were arranged in patterns that resembled Neanderthal dental morphology. The bones themselves were thick and robust, even by heidelbergensis standards. Most remarkably, when researchers managed to extract and sequence ancient DNA from some of these remains, they found that genetically, these individuals were already on the Neanderthal lineage. They weren't Homo heidelbergensis evolving into Neanderthals. They were proto-Neanderthals, early representatives of a lineage that had already split from the populations that would eventually become modern humans. This discovery pushed back the timeline for the Neanderthal divergence significantly. It meant that by 430,000 years ago, maybe even earlier, European and African populations of heidelbergensis had already separated enough to be on distinct evolutionary paths. The split between the lineage leading to Neanderthals and the lineage leading to modern humans happened somewhere between 500,000 and 600,000 years ago, far earlier than many researchers had previously thought. What drove this split? The most likely answer is geography and climate. By 500,000 years ago, glacial conditions in Europe were becoming increasingly severe. The Sahara Desert, which oscillated between desert and grassland with the climate cycles, would have created a barrier between African and European populations during dry periods. Populations on either side of this barrier were isolated from each other, unable to exchange genes or cultural innovations. In isolation, they began adapting to their specific environments, and the environments couldn't have been more different. African heidelbergensis populations were dealing with tropical and subtropical conditions, with abundant sunlight, seasonal rainfall patterns, diverse plant and animal communities. European populations were dealing with Ice Age conditions, with long harsh winters, limited plant diversity, and the need to survive extended periods of cold that would kill an unprepared individual in hours. The European populations responded with a suite of adaptations that would eventually produce the classic Neanderthal body plan. They became more robust, with thicker bones and heavier muscle attachments. This wasn't just about being strong, though strength mattered. This was about heat retention. A stocky, compact body conserves heat better than a tall, linear one. The same principle explains why modern humans native to cold climates tend to be more compact than those from the tropical regions. The face began to change in distinctive ways. The nose became larger, with more internal volume. This seems counterintuitive. Wouldn't a large nose be a liability in the cold, more surface area to freeze? But a large nasal cavity serves a crucial function. It warms and humidifies incoming air before it reaches the lungs. When you're breathing air that's well below freezing, having a large nose that can warm that air before it damages delicate lung tissue becomes a survival advantage. The face also began projecting forward more, creating what anthropologists call midfacial prognathism. The entire middle part of the face, from the nose to the cheekbones, jutted out further than in other human species. We're not entirely sure why this feature evolved. It might be related to the large nose adaptation. It might be about bite force, making the front teeth more effective tools. It might even be a byproduct of other changes, a feature that came along incidentally with adaptations that were directly selected for. The brain was changing too, growing larger even than heidelbergensis brains. By the time we get to classic Neanderthals 100,000 years later, they would have brain sizes averaging 500 cubic centimeters, actually larger than modern human averages. But 400,000 years ago, this expansion was just beginning. The proto-Neanderthals at Cima de los Huesos had brains around 1200 to 1300 cubic centimeters, in the range of large heidelbergensis but trending upward. What drove this brain expansion? The harsh environment might have created selection pressure for improved planning and problem-solving abilities. Surviving Ice Age winters required careful preparation, storing food, maintaining fire, creating adequate shelter. Mistakes were more costly in environments where the margin for error was smaller, but brain expansion comes with costs. Larger brains require more energy, more calories to maintain. They require changes to childhood development, longer periods of dependency when the young brain is growing. They require changes to female anatomy to accommodate giving birth to large-headed infants. Natural selection doesn't favour larger brains unless the benefits outweigh these substantial costs. The cultural adaptations these proto-Neanderthals were developing show sophistication that might explain the brain size increase. By 400,000 years ago, European populations were showing advanced use of fire, more elaborate toolkits, possible early forms of shelter construction. Some sites show evidence of wooden structures, post holes and arrangements of stones suggesting deliberate architecture. They were also hunting the most dangerous megafauna in Europe: cave bears, massive creatures that could weigh 1,500 pounds, woolly rhinoceroses and mammoths, though these wouldn't reach their full ice-adapted forms until later, straight-tusked elephants in the warmer periods. Successfully hunting these animals required sophisticated planning, coordination, and execution. One mistake could kill multiple hunters. The social implications of these hunts were significant. You needed groups large enough to bring down big game but small enough to feed from the available resources. You needed strong social bonds that kept groups cohesive during the long, dark winters when resources were scarce and tensions might run high. You needed ways to resolve conflicts without violence that could cripple the group. These proto-Neanderthals were also developing the earliest hints of symbolic behaviour that would become more elaborate in their descendants. The pink quartz hand axe at Cima de los Huesos might be evidence of this. If it was deliberately placed with the dead, as some researchers believe, it suggests they had concepts of ritual, of doing things for symbolic rather than purely practical reasons. There's also increasing evidence of pigment use in this period, not just ochre, which as we discussed appears at heidelbergensis sites across the Old World, but manganese dioxide, a black mineral that creates dark pigments. The presence of both red and black pigments suggests they valued colour variation, that they were using pigments for some purpose beyond any practical application. Were they painting their bodies? Were they decorating objects? Were they using pigments in ritual contexts? We can't know for certain. But the presence of pigments that had to be collected, processed and transported suggests they served some important function in proto-Neanderthal life. The linguistic capabilities of these early Neanderthals remain debated. The hyoid bone, which we discussed earlier, proves they had the anatomical capacity for speech, but anatomy doesn't prove use. Some researchers argue that the large Neanderthal brain, the complex tool-making, the evidence of coordinated hunting and social organisation all point to language as a necessity. You simply couldn't maintain these complex behaviours without some form of sophisticated communication. Others point out that many complex animal behaviours occur without language. Chimpanzees coordinate group hunts without true language. Ravens demonstrate sophisticated problem-solving without speech. Maybe proto-Neanderthals had something less than full language but more than simple vocalizations, a communication system adequate for their needs but different from what modern humans possess. The isolation of European populations from African ones had another important effect. It limited genetic diversity. When populations are separated and relatively small, they're subject to genetic drift, random changes in gene frequencies that can lead to distinctive traits emerging and becoming fixed in the population. Some Neanderthal features might be adaptations to cold climates. Others might simply be the result of genetic drift, neutral variations that became characteristic of the population by chance. This raises an interesting question about what we should call these 400,000-year-old Europeans. Are they late Homo heidelbergensis? Are they early Neanderthals? Are they a transitional form that doesn't fit neatly into either category? The truth is, these categories are somewhat arbitrary. Evolution is gradual. There's no single moment when a heidelbergensis gave birth to a Neanderthal. Instead, there's a continuum, a slow transformation over thousands of generations. At some point, we can look at a population and say definitively, yes, these are Neanderthals. At another point, we can say definitively, no, these are still heidelbergensis. But in between, there's a grey area where the answer depends on which features you emphasize. The cima de los huesos individuals fall into this grey area. They show enough Neanderthal features that some researchers call them early Neanderthals. They show enough heidelbergensis features that others still classify them as heidelbergensis. The genetic evidence suggests they were on the Neanderthal lineage, which supports calling them Neanderthals. But genetically being on the Neanderthal lineage and being a full Neanderthal aren't quite the same thing. What we can say with confidence is that 400,000 years ago the Neanderthal Genesis was well underway. The populations that would eventually become the Neanderthals we know from 100,000 to 40,000 years ago were already distinct, already adapting to Ice Age Europe, already developing the features that would make them so successful in this harsh environment. And they were successful. Neanderthals would go on to dominate Europe for hundreds of thousands of years. They would develop elaborate cultures, create sophisticated tools, possibly even develop early forms of art and symbolic expression. They would adapt to some of the harshest conditions any human species ever faced and thrive. But that success was still in the future. In 400,000 BCE, proto-Neanderthals were just beginning their evolutionary journey. They were caught between what they had been and what they would become. They were humans in transition, populations adapting to their environment in ways that would eventually make them one of the most distinctive human species that ever existed. And somewhere in Africa, other heidelbergensis populations were undergoing their own transformation, adapting to different environments, facing different challenges, developing different solutions. These populations would eventually give rise to us, to Homo sapiens. But that transformation would take hundreds of thousands of years, and its details remain even more mysterious than the Neanderthal Genesis we can glimpse in European caves. While we can trace the Neanderthal Genesis in Europe through sites like Cima de los Huesos, with their relatively abundant fossils and clear transitional features, the story in Africa is maddeningly obscure. This is particularly frustrating because Africa is where the most important transformation in human evolution would eventually occur. Somewhere on that continent, Homo heidelbergensis populations were beginning the long evolutionary journey that would eventually produce Homo sapiens. Our species, us. But if you're hoping for a clear narrative with well-documented stages and abundant fossils showing the gradual emergence of modern human features, you'll be disappointed. The African fossil record from 400,000 years ago is sparse, fragmentary, and full of gaps that make the European record look comprehensive by comparison. Why is this? Why do we know so much more about what was happening in Ice Age Europe than we do about the continent where modern humans evolved? Part of the answer is geology. The geological processes that preserve fossils work best in certain environments. Caves and rock shelters, where sediment accumulates gradually over time, burying bones and protecting them from the elements. River deltas and lake beds, where flooding deposits layers of sediment that can entomb remains. Volcanic ash falls that can bury entire landscapes. Europe had many such sites. The cave systems of Spain and France, the river valleys of England and Germany, the lake beds of Italy. These environments preserved fossils relatively well, giving us a decent sample of European heidelbergensis and their proto-Neanderthal descendants. Africa had some of these environments too, particularly in the Rift Valley region of East Africa, where tectonic activity created lakes and volcanic deposits. But Africa is a massive continent with diverse environments, and many regions simply don't preserve fossils well. Tropical forests where high heat and humidity cause rapid decomposition. Grasslands where remains are exposed to scavengers and weathering. Ancient coastlines now submerged under ocean water. The result is that our view of African human evolution is based on fossils from a limited number of sites, mostly in East Africa and South Africa, with huge gaps between them. We have snapshots, moments frozen in time, but the connections between them are often unclear. For 400,000 years ago specifically, we have very few African hominin fossils. There's a skull from Bodo in Ethiopia, dated to about 600,000 years ago, showing heidelbergensis features. There are remains from various South African sites in the same general time range. But from 400,000 years ago itself, the pickings are slim. This creates a massive hole in our understanding of our own origins. We know Homo sapiens emerged in Africa. We know heidelbergensis populations were present in Africa 400,000 years ago. We can infer that these populations gradually evolved into our species over the following few thousand years. But the details of this transformation, the intermediate forms, the specific adaptations that led to modern human anatomy and behaviour, Most of this is lost to us. What we can do is work backwards from what we know about early Homo sapiens and forwards from what we know about Homo heidelbergensis, trying to identify what must have changed between them, even if we can't see exactly when or how. The most obvious change is in skull shape. Homo heidelbergensis had elongated skulls with pronounced brow ridges and projecting faces. Early Homo sapiens had more globular skulls, reduced brow ridges, and flatter faces. The skull of a heidelbergensis is immediately recognizable as archaic. The skull of an early Homo sapiens, while showing some features that differ from modern humans, is clearly within the range of our species. This transformation in skull shape reflects changes in brain organization. It's not just that sapiens' brains were larger, though they were somewhat bigger on average. It's that the brain was reorganized, with different proportions between different regions. The frontal lobes, associated with planning and abstract thinking, were expanded. The parietal lobes, involved in spatial reasoning and tool use, were elaborated. The overall shape became more rounded, suggesting changes in brain development during childhood. These changes didn't happen overnight. They must have occurred gradually over hundreds of thousands of years of evolution. But without fossils showing the intermediate stages, we can only speculate about the sequence of changes and what drove them. The postcranial skeleton, everything below the skull, also changed. Heidelbergensis were robustly built with thick bones and heavy muscle attachments. Early sapiens were more gracile, with thinner bones and lighter build. Again, this transformation must have been gradual, but we can't track it in detail because we lack the fossils. Some researchers have tried to identify specific environmental pressures that might have driven the evolution of modern human features in Africa. The climate was changing, oscillating between wet and dry periods that would have transformed landscapes repeatedly. During wet periods, lakes expanded and forests grew. During dry periods, deserts spread and water became scarce. These oscillations would have created intense selection pressure. Populations had to be flexible, able to adapt to changing conditions. Some researchers argue this variability itself drove the evolution of cognitive flexibility, the ability to solve new problems and adjust strategies as circumstances changed. Modern humans are characterized by behavioral flexibility in ways that other human species weren't. Maybe this flexibility evolved in response to Africa's unstable climate. But this is speculation. It's a reasonable hypothesis supported by some evidence, but it's not proven. Other researchers argue that climate change affected all human populations, not just African ones, yet only African populations evolved into Homo sapiens. So climate alone can't be the full explanation. Another theory focuses on population structure. Genetic evidence from modern humans suggests our ancestors went through periods of population fragmentation followed by reconnection. African populations split into isolated groups during harsh climate periods, then came back together when conditions improved. This pattern of isolation and admixture might have created conditions favourable for rapid evolution. When populations are isolated, they can diverge, developing different adaptations to local conditions. When they reconnect, the different adaptations can be shuffled together, potentially creating new combinations that are advantageous. This process, called population structure evolution, might have accelerated the evolution of modern human features. But again, this is theoretical. We can see evidence of this process in the genes of modern humans, but we can't directly observe it happening 400,000 years ago. We're inferring ancient population dynamics from modern genetic patterns, which requires numerous assumptions. One thing we can say with more confidence is that tool technology in Africa was changing during this period. Around 300,000 years ago, we see the emergence of what's called Middle Stone Age technology in Africa. This represents a shift from the Acheulean hand axes that had dominated for over 1 million years to more sophisticated tools made using prepared core techniques. Prepared core technology involves shaping a stone core in advance, so that when you strike it, you get flakes of predictable size and shape. This requires more planning and skill than simply knocking flakes off a core randomly. It suggests more sophisticated cognition, the ability to visualize the final product before you start and work toward it systematically. The timing is suggestive. Middle Stone Age technology appears roughly when we'd expect populations to be transitioning from heidelbergensis to early sapiens. Some researchers argue the new tools reflect the cognitive changes that were making these populations more human in the modern sense. But the connection isn't proven, and frustratingly, we have very few fossils directly associated with the earliest Middle Stone Age sites, We have the tools, but we often don't know who made them. Were they made by late heidelbergensis, by transitional populations, by early sapiens? Without fossils found with the tools, we can't be certain. There's also evidence of early symbolic behaviour appearing in Africa during this period. Ochre use becomes more common and more elaborate. Some sites show ochre that's been engraved with geometric patterns, possibly the earliest abstract designs. Beads made from shells appear in the archaeological record, evidence of personal adornment. These behaviours are characteristic of modern humans. We're a species obsessed with symbolism, with creating meaning through objects and images. Finding evidence of symbolic behaviour in Africa hundreds of thousands of years ago suggests that modern human cognition was emerging during this period. But again, we often don't have the fossils to connect these behaviours to specific populations. We know someone in Africa was creating symbolic objects and using advanced tools. We just don't know exactly what they looked like or where they fit on the evolutionary tree leading to modern humans. The frustration scientists feel about these gaps is profound. This is literally the origin of our species we're trying to understand, the transformation that made us what we are. And we're doing it with a handful of fragmentary fossils separated by hundreds of thousands of years and scattered across an entire continent. Imagine trying to understand the history of the United States, but all you have are 3 photographs from different centuries, a few scattered letters, and some artifacts whose purpose isn't entirely clear. You could make educated guesses about what happened between the snapshots, but you'd be missing most of the story. That's what we're dealing with in African human evolution. We have the before picture, Homo heidelbergensis, we have the after picture, Homo sapiens, and we have enormous uncertainty about the journey between them. Recent discoveries have started to fill in some gaps. In 2017, fossils from Jebel Irhoud in Morocco, dated to about 315,000 years ago, showed a mix of archaic and modern features that might represent a transitional form. The skulls had some modern features like smaller faces, but retained archaic features like elongated brain cases. They're not quite Homo sapiens as we define it today, but they're clearly moving in that direction. This discovery pushed back the origin of Homo sapiens by about 100,000 years from previous estimates. It also suggested that the evolution of modern humans happened across Africa, not just in one region. The Jebel Irhoud population was in North Africa, thousands of miles from the East African sites where many other important fossils have been found. This pattern of Pan-African evolution fits with the genetic evidence suggesting our ancestors were structured into multiple populations across the continent. Modern humans didn't emerge from a single population in a single location. We emerged from a complex network of populations spread across Africa, sometimes isolated from each other, sometimes interbreeding, gradually accumulating the features that make us modern. But 400,000 years ago, this process was just beginning. The populations that would eventually become Homo sapiens were still mostly heidelbergensis, still showing primarily archaic features. The transformation was underway, driven by forces we can only partly understand, but it wouldn't be complete for hundreds of thousands of years yet. And this raises profound questions about what it means to be human. If the evolution from heidelbergensis to sapiens was gradual, happening over hundreds of thousands of years, at what point do we draw the line and say, here, this is when humans became truly modern? Is it when anatomically modern features appeared? That would be somewhere around 300,000 years ago based on current evidence. Is it when behaviourally modern traits emerged? That might be later, perhaps 100,000 years ago, when we see evidence of art, complex tools and elaborate symbolic expression. Or is it when modern humans started spreading out of Africa and replacing other human species? That wouldn't be until 70,000 years ago or later. The honest answer is there's no single moment when we became human. It was a process, not an event. And 400,000 years ago, African populations were in the middle of that process. Not fully heidelbergensis anymore, but not yet sapiens either. Something in between, something transitional, populations that were becoming what we are but hadn't arrived yet. The African mystery remains one of the deepest in all of paleoanthropology. We know this continent holds the answers to our most fundamental questions about human origins. We know somewhere in Africa's savannas and forests and rift valleys, our ancestors were evolving the features that make us unique. We just can't see most of it happening. The fossil record is too sparse, the gaps too large, the evidence too fragmentary. But researchers keep looking. Every year brings new discoveries, new techniques for extracting information from fossils, new ways of analysing ancient DNA and interpreting archaeological sites. Slowly, piece by piece, the picture becomes clearer. We may never have a complete record of African human evolution, but we're getting closer to understanding the broad patterns, if not all the details. And perhaps there's something fitting about this mystery. The origin of our species, the transformation that made us what we are, remains partially hidden, requiring us to use our distinctively human capacities for inference and imagination to fill in the gaps. We're using our modern human minds to try to understand how those minds evolved in the first place. It's a strange loop, consciousness examining its own origins, and the gaps in the record make the mystery all the more profound. So here we are, looking back across 400,000 years at a world that no longer exists. A world where multiple human species walked the Earth simultaneously, where ice sheets advanced and retreated across continents, where megafauna roamed and died, where our ancestors struggled to survive in conditions we can barely imagine. What does this vanished world tell us about ourselves? What can we learn from the humans who lived then, most of whose lineages ended in extinction? Let's start with the question that haunts everyone who studies this period. Why did most human species go extinct while one lineage, our lineage, survived to become the dominant species on Earth? There's no simple answer, and anyone who tells you otherwise is oversimplifying. Evolution doesn't follow neat narratives with clear heroes and villains, with inevitable winners and deserving losers. Success and failure in evolution are determined by the match between a species' capabilities and the challenges they face, and that match depends on circumstances that are often largely random. Homo erectus survived for nearly 2 million years, far longer than our species has existed. By any measure, they were incredibly successful. But they eventually went extinct, probably sometime between 400,000 and 100,000 years ago, replaced by or outcompeted by species with larger brains and more flexible behaviours. Were they evolutionary failures? Only if you measure success solely by who's alive at the end. By the metric of persistence across deep time, they were the most successful human species ever. Homo heidelbergensis gave rise to both Neanderthals and modern humans, then disappeared as a distinct form. But their genes live on in their descendants. Every Neanderthal that ever lived was descended from heidelbergensis populations. Every modern human carries heidelbergensis ancestry. Did heidelbergensis go extinct, or did they transform into something new? The question itself reveals how arbitrary our species categories can be. The Neanderthals, who were just beginning to emerge 400,000 years ago, would go on to dominate Europe for hundreds of thousands of years. They developed sophisticated cultures, created complex tools, possibly even produced art. They survived Ice Age conditions that would kill unprepared modern humans in hours, yet they eventually went extinct around 40,000 years ago, shortly after modern humans began spreading into Europe. Did modern humans cause their extinction? The timing is suggestive, but causation is hard to prove. Maybe we outcompeted them for resources. Maybe we brought diseases they had no immunity to. Maybe we interbred with them so extensively that they were absorbed into our population rather than going extinct. The genetic evidence shows that non-African modern humans carry Neanderthal DNA, proof that interbreeding occurred, but whether this interbreeding contributed to Neanderthal extinction or was irrelevant to it remains debated. What we can say with confidence is that survival depends on more than just individual capabilities. It depends on being in the right place at the right time with the right adaptations for the challenges you face. Homo sapiens evolved in Africa, the continent with the most diverse and variable environments, facing intense pressure to be flexible and adaptable. This prepared us well for spreading into new environments and adjusting to changing conditions. Other human species evolved in more stable environments or specialized for specific niches. Homo erectus populations in tropical Java, Neanderthals in Ice Age Europe. These specializations made them very good at surviving in their specific environments, but potentially less capable of adapting when those environments changed, or when they encountered competition from a highly adaptable generalist species like Homo sapiens. But this explanation only goes so far. It's too neat, too focused on inevitability. The truth is probably messier, involving contingency and chance as much as any inherent advantages modern humans possessed. What if the climate had shifted differently? What if Homo erectus populations had developed larger brains and more flexible behavior before they encountered competition? What if Neanderthals had spread into Africa and Asia instead of remaining primarily in Europe? The outcome might have been very different. We might be living in a world where multiple human species still coexisted, or where a different human lineage became dominant, or where humans of any species never developed the capabilities that led to civilization. The survival of our lineage wasn't inevitable. It was contingent on thousands of factors, most of which we can't even identify. And this should make us humble about our place in the world. We're not the pinnacle of evolution, the inevitable result of progress towards something better. We're the survivors of a highly competitive process that eliminated most of our relatives. We're here partly because our ancestors were capable and adaptable, but also partly because of luck, because environmental changes favoured our particular combination of traits at crucial moments. Looking back at 400,000 years ago also gives us perspective on what it means to be human. We tend to think of humanity as equivalent to Homo sapiens, but the reality is far richer. Humanity is the entire lineage going back millions of years, encompassing dozens of species, each one human in its own way. Homo erectus was human. They walked upright, made tools, used fire, raised children, formed social bonds. They were conscious beings navigating a complex world. The fact that they looked different from us, had smaller brains than us, went extinct while we survived, none of this makes them less human. Homo heidelbergensis was human. Hunting elephants with wooden spears, caring for their injured, possibly burying their dead with grave goods. They were our ancestors in the most literal sense, and the line between them and us is arbitrary, a convenient label applied to a gradual transformation. The proto-Neanderthals at Cima de los Huesos were human, adapting to Ice Age conditions, developing the features that would make their descendants so successful in Europe. They were on a different evolutionary path than us, but they were no less human for it. Even the species we haven't discussed, the ones we barely know about because their fossil record is so sparse, they were all human. Part of the great bushy family tree of humanity, branches that grew and flourished for a time before being pruned by the relentless forces of natural selection and environmental change. Understanding this deep history of humanity also changes how we think about ourselves today. Modern humans are remarkably homogeneous compared to the diversity that existed 400,000 years ago. We're all one species, capable of interbreeding, sharing the vast majority of our genetic heritage. The differences between human populations today, differences in skin colour, facial features, body build, are superficial variations on a single theme. This wasn't always the case. There was a time when humanity was diverse at the species level, when encountering another human might mean encountering a different kind of human, someone similar but fundamentally different. That diversity is gone now. We're the only human species left, and we've been alone for at least 40,000 years, probably longer. Some people find this lonely. The idea that we once had cousins, other human species sharing the world with us, and now they're all gone. We're the only ones left to tell the story, the only ones who remember, and even our memory is fragmentary and incomplete. But there's also something profound about our singularity. Every human alive today, all 8 billion of us, we're all part of the same species. We can all communicate, cooperate, interbreed. Despite our conflicts and divisions, we're fundamentally more alike than different. The diversity that once existed at the species level has been replaced by diversity at the cultural level, thousands of different ways of being human while remaining biologically united. The gaps in our knowledge, the massive uncertainties about what happened 400,000 years ago, these are frustrating but also appropriate. The past doesn't preserve itself for our convenience. Most of what happened leaves no trace. The fossils we find are the exceptions, the lucky accidents of preservation that give us glimpses into vanished worlds. Every new discovery fills in a small piece of the puzzle, but also reveals how much we still don't know. The Cima de los Huesos fossils told us about proto-Neanderthals, but raised new questions about the timing of the Neanderthal divergence. The Jebel Irhoud fossils pushed back the origin of Homo sapiens, but complicated our understanding of what anatomically modern means. Each answer generates new questions. This is how science works, especially in fields like paleoanthropology, where the evidence is sparse and fragmentary. We build models based on available data, knowing those models are provisional, subject to revision as new discoveries emerge. We hold our theories lightly, ready to abandon them if better explanations come along. But some things we can be confident about. Multiple human species coexisted 400,000 years ago. Homo heidelbergensis in Europe and Africa, Homo erectus in Asia, proto-Neanderthals emerging in Europe, early Sapiens lineages beginning to differentiate in Africa. These species competed for resources, possibly encountered each other, definitely shaped each other's evolution through their very existence. The world they inhabited was harsh and unstable, locked in glacial cycles that transformed entire continents. Climate change wasn't an abstract threat, but a constant reality, forcing adaptation or extinction. The megafauna they hunted were larger and more dangerous than almost anything alive today. Survival required constant vigilance, sophisticated tools, social cooperation, and accumulated knowledge passed across generations. These humans were cognitively sophisticated in ways we're only beginning to appreciate. They planned, they learned, they taught, they possibly had language or proto-language. They cared for their injured, buried their dead, possibly created symbolic objects. They were conscious beings with inner lives we can only imagine, experiencing the world in ways that were probably both familiar and alien to how we experience it. Most of their lineages ended in extinction, but they're not gone, not really. Homo erectus genes might persist in modern human populations through ancient interbreeding. Homo heidelbergensis lives on in us and in the Neanderthal DNA that many of us carry. The cultural innovations these species developed, fire use, sophisticated tool-making, cooperative hunting, these became part of humanity's heritage, passed down and elaborated by each successive generation. And the questions they faced, how to survive in changing environments, how to cooperate despite conflicts, how to balance tradition with innovation, these are still our questions. The details have changed. We're not hunting mammoths or sheltering from cave bears, but we're still trying to figure out how to live together on a finite planet with limited resources and an unstable climate. We're still balancing individual needs against group survival. We're still teaching the next generation while trying to solve problems our ancestors never imagined. In that sense, the story that began 400,000 years ago is still being written. We're the latest chapter, not the conclusion. What happens next depends on whether we can apply the lessons of our evolutionary history, whether we can be as adaptable as our ancestors, whether we can cooperate at scales they never needed to consider. The humans of 400,000 years ago couldn't have imagined what their descendants would become. They couldn't have predicted that one lineage would survive to build cities, develop agriculture, create art and music and literature, eventually reach the moon and send robots to Mars. They were just trying to survive, to find food and water, to stay warm through the winter, to raise their children and pass on their knowledge. But their struggles made our existence possible. Every adaptation they evolved, every innovation they developed, every crisis they survived, these became part of our heritage. We are who we are because of what they were, because of the challenges they faced and the solutions they found. As you drift off to sleep, perhaps you can imagine them. A band of Homo heidelbergensis around a fire in Ice Age Europe, the night sky above them full of stars they couldn't name, a family of Homo erectus in tropical Java, watching the sunset over forests that no longer exist. Proto-Neanderthals in a Spanish cave, placing a pink quartz hand axe with their dead for reasons we can only guess. They're gone now, all of them. But they were real. They lived and loved and struggled and died. They were human as we are, just in different ways. And their story, fragmentary and incomplete as it is our story too. The story of multiple human species fighting to survive in a world that was constantly changing. The story of our family tree at its bushiest, when humanity meant more than just us. Sleep well, knowing that you're the descendant of survivors, that every human who contributed to your ancestry faced challenges we can barely imagine and overcame them, that the genes you carry, the cultures you inherit, the very capacity you have to think about these questions, all of it is the product of millions of years of evolution, hundreds of thousands of years of human struggle and triumph. The world 400,000 years ago is gone, but its echoes remain, written in our bones, coded in our DNA, embedded in the deepest structures of how we think and live. We are the children of that vanished world, carrying forward the legacy of species that no longer exist, continuing a story that began long before us and will continue long after we're gone. Good night.